Welcome back. Today we're going to look at full text search. Full text search creates an inverted index so that we can find words in a large body of text. We'll do this inside of MemSQL alongside of our other queries, our relational queries, and our normal filters. So let's dive in. Let's create a database. And then we'll use that database, create a table. Now this table is intentionally a clustered column store. Full text is currently only available on column stores, and full text is only available on text columns or text-like columns. So in this case, I'm creating a full text index on the content column. I could also include the author in the title column, but I couldn't include the publish date or the line number. Thanks to Gutenberg.org for these books. Let's load all these books into the database. Now in each line of the book, we go grab the critical details. So each line will include the title, the author, the publish date, the line number in that text, and the actual text content. So now that we've got that started, let's start that pipeline. Almost instantly, we'll get all of our data loaded into MemSQL. We can take a look at all of the books. We've got 38,000 lines that we just loaded in real fast. Let's take a look at the pipelines. Yep, all of our pipelines succeeded. That's great. Now to get the full text index to update really quickly, we'll call table flush. Ordinarily, we could just wait until that content came into place. And let's take a look at all the books. So we have a set of books, and we have this number of lines of text for each book. That's perfect. So now normally we would do a query like this. Let's go looking for all the books that have the word Alice in their line. That was okay. That wasn't great. It was still pretty fast though. And so here's all the lines from Alice in Wonderland that say Alice in the text. That's pretty cool. Let's leverage the full text index and see if we can make that faster. Let's select all of the lines where that content includes Alice. There we go, we've got all the lines. We can see in each line, here's the word Alice, and it is the full word. Let's take a look at that, and we'll put this inside of a where clause. So only where this matches will we grab the title. We'll grab the title and the count of lines. So we're grouping by 1, the title, and we're grabbing the count of lines. So there's 164 lines in the book Alice in Wonderland that reference Alice. That's pretty cool. Let's look for Peter. Here's all the lines. Ooh, in The Adventures of Tom Sawyer, we have Peter. In Peter Pan, we have a whole lot of Peter. Let's do that query again to take a look at the books and lines. Yep, 233 lines in Peter Pan and 6 lines in Tom Sawyer that have the name Peter. Well, what would it be if we had a mashup between Alice and Peter? What if Alice in Wonderland came and visited Peter Pan? Here's all the lines that have Alice or Peter. So we can see here's a bunch of Alice in Wonderland lines. And here's a bunch of Peter Pan lines. So we see all of the content. Now let's check. Is there a mashup between Alice and Peter? Nope, we don't have any books that reference both Alice and Peter. Now we can do some other interesting things. We'll look for Huckleberry Finn and Tom Sawyer. Now in this case, we may find Huckleberry or we may just find Huck. So let's do Huck and then star. Star represents 0 or more characters. We could also do a question mark representing a single character. So here's all the lines that include Huckleberry or Huck or Tom. Let's grab the books that include that. Ooh, we've got references to Huck or Tom in 4 of our books. That's perfect. Let's find the lines that reference both Huck and Tom. Okay, so here's Huck and here's Tom. Here's Huck and here's Tom. These are the lines that reference both characters. Here's all the books. Adventures of Huckleberry Finn has exactly 1 line that references both Huck and Tom. And Adventures of Tom Sawyer references Huck and Tom in 11 lines. That's really cool. We could use that star to find both Huck and Huckleberry. Next up, let's highlight the matching lines. Back with Alice, let's go find all of the lines from books where we match that full text index of Alice. And then with each of those lines, let's highlight in that content the Alice keyword. So previously we just had text, but now we have this HTML bold tag over the top of that, highlighting that particular term. We also have unique terms and offset that will give us a little bit more context around that. That's cool. We can see all of the lines that say Alice, and we could choose to highlight this in a web page just by using that bold tag to be able to reference that. How about Huck and Tom? Okay, so we're going to go match our content against Huck and Tom, so lines that include both Huck and Tom. And then we're going to highlight either the term Huck or the term Tom, or both. Let's do that. So here's Huck, and here's Tom. Both of them are bold, Huck and Tom. Here's one that says Huckleberry, and Huckleberry isn't highlighted. We can't say star here because we can't just say reference any kind of word, but we could say or Huckleberry. And now we're able to highlight the Huckleberry lines too. Let's spell Huckleberry correctly. Now we can reference the Huckleberry lines too. So here's the ones that highlight Huck and Tom and Huckleberry, and all of those work just fine. You can grab this SQL file in the description below. And when you're done, stop the pipeline for books, drop the books table, and if you want to, you can clean up the library database as well. Full text search is able to search through all kinds of content in very large and very dispersed columns. Grab full text search from the docs in the link below, and have a lot of fun with full text search.